In today's lecture, we are solving out the question related to the differential equation. Question says that solve the differential equation d square minus 3d plus 2 into y is equal to e the power x. Given that y is equal to 3 and dy is equal to 3 when x is equal to 0. Solution. Solution. At first write down here auxiliary equation is given by. The given equation is d square minus 3d plus 2. So auxiliary equation is given by. Here in the short form auxiliary equation is write down AE. Here AE is given by. We know that for finding out the auxiliary equation, we put capital D is equal to m and it is equal to 0. Then we get m square minus 3m plus 2 is equal to 0. Now solve out by the splitting of the middle term. When we solve out by the splitting of middle term, we get m square minus 2m minus m plus 2 is equal to 0. When we solve out a codic equation by the splitting of middle term, we get always two roots, and the roots are, take out m as a common, then we get m minus 2, m minus 2, again minus 1 is common, then we get m minus 2 is equal to 0. Here we get two factors. First one is m minus 2 and another is m minus 1. M minus 2 m minus 2 and m minus 1 is equal to 0. Now put equal to 0 one by one. When we put m minus 2 is equal to 0, we get m is equal to 2. M is equal to 2. When we get m minus 1 is equal to 0, we get m is equal to 1. Now CF is given by. Hence CF is equal to, we know that when two roots are unequal, then CF is given by C1 e the power ax plus C2 e the power bx. So here C1 e the power x plus C2 e the power 2x. This is the CF. Now PI is equal to, for finding out the PI, write down the RHS part in numerator, that is e the power x. That is e the power x upon, in the denominator is d square minus 3d plus 2, the function of d square minus 3d plus 2. Now apply the identities. First identity of the says that e the power ax upon fd is given, then we can write down e the power ax upon fa. fa stands for function of a, in which we can, capital D is replaced by small a. Now when we put pi is equal to e the power x upon d square minus 3d plus 2, here a is equal to 1, so 1 square minus 3 into 1 plus 2, that's, denominator becomes 0. That is not possible. So pi is equal to pi is equal to e the power x is as it is, and we write down the factor of the denominator. Factor is d minus 2 and d minus 1. D minus 2 and d minus 1. Now apply the identity, then we get pi is equal to e the power x is as it is. The value of a is 1, so put the at the place of d is 1, then 1 minus 2, 1 minus 2, and 1 minus 1 is 0, so don't write the 1, d minus 1. Now again apply the identity. Identity says that if e the power ax is given in numerator and in denominator is d minus a the power n, d minus a the power n, then solution is x the power n upon factorial n into e the power ax, into e the power ax. Now here solution is given by pi is equal to minus e the power x, 1 minus 2 is minus 1 upon into x the power n is x the power 1 upon factorial 1, upon factorial 1. So pi is equal to minus x into e the power x, x into e the power x. Hence general solution is given by, hence general solution is y is equal to CF plus PI. Y is equal to CF stands for complementary function, PI stands for particular integral. So y is equal to CF is C1 e the power x plus C2 e the power 2x. C1 e the power x plus C2 e the power 2x, and pi is minus x into e the power x. Now according to given, this is our solution, but according to given, y is equal to 3 when x is equal to 0. According to given, its equation 1. According to given, according to given, according to given, y is equal to 3 when x is equal to 0. Y is equal to 3 when x is equal to 0. So it's become y is equal to 3 when x is equal to 0. So it's become 3 is equal to C1 e the power 0 plus C2 e the power 2 into 0 minus 0 into e the power 0. So it become 3 is equal to C1 plus C2. The first equation is 3 is equal to C1 plus C2. Its equation second. And second condition says that dy is equal to 3 when x is equal to 0. dy is equal to 3 dy is equal to 3 when x is equal to 0. Carry out the differentiation of equation 1. Carry out differentiation of equation 1. We get dy by dx is equal to, the differentiation of e the power x is always e the power x and the constant c1 is 0. So c1 e the power x. Second is c2 e the power 2x. It's become 2c2 e the power 2x. फिर minus x into e the power x. Carry out the differentiation by u into v form minus e the power x minus x e the power x minus x e the power x. I think you understand how we can solve out the differentiation of u into v is at first u is carried out v as it is, v carried out u as it is. Now dy by dx is equal to so and so. Here put the value dy by dx is equal to 3 c1 e the power 0 plus 2c2 e the power 2 into 0 minus e the power 0 minus 0 into e the power 0. It became 3 is equal to c1 plus 2c2. The value of e the power 0 is always 1, so minus 1. Now it became c1 plus 2c2 is equal to 4. Its equation third. From equation second and third. From equation second and third, we get c1 plus c2 is equal to c1 plus c2 is equal to c1 plus c2 is equal to 3 and c1 plus 2c2 is equal to 4. Now by the simple change we can write down minus is became minus c2 is equal to minus 1 and c2 is equal to 1. When we put c2 is equal to 1 in equation second, then we get c1 is equal to 2. So c2 is equal to 1 and c1 is equal to 2. I think you understand how we can solve out. Now general solution is given by y is equal to c1 e the power x. So 2 e the power x plus c2 e the power 2x. So e the power 2x minus pi is x into e the power x. Pi is x into e the power x. So write down x into e the power x. It's our final solution. I think you understand how we can solve out the given question by the using of auxiliary equation, and solved out by the algebraic identities and different methods. And we know that when two roots are equal, how we can represent and how we can react. Now lecture is finished. Jai Hind, Jai Bharat.